The objectives for section 4.2 are mostly involving this vertex form. You'll have to know what vertex form is, how A affects the parabola, where the vertex is, how to find the maximum or the minimum, what the axis of symmetry is, and how to convert from standard form into vertex form. So the first thing we'll do is look at how A affects a parabola. Here's a plain old regular parabola, and we know that as you travel from the vertex, which is right here, over 1 unit, you're going to go up 1 unit. If you go over 2 units, 2 squared is 4, so the next point is at 4. And if you travel over 3 units, you know that 3 squared is 9, which is off the screen. If we change the coefficient into something, for example, like 2, it looks like the parabola goes up faster, and that kind of makes sense. If I go over 1, 1 squared is 1, but if I multiply that by 2, I'm now going up 2 units. If I go over 2 units, 2 squared is 4, but 4 times 2 is 8, which is way off the screen. And if I go over 3 units, 3 squared is 9, but 9 times 2 is 18, so the parabola is going to hit at 18. If the coefficient in front of the variable is less than 1, say 1/2, that's going to cause the parabola to be wider. Going over 1 unit times 1/2 puts me at 0.5. Going over 2 units, 2 squared is 4, and 4 times 1/2 is 2. And going over 3 units, 3 squared is 9, 9 times 1/2 is 4.5. So the coefficient of A changes the width of the parabola, with numbers bigger than 1 causing parabolas to go up faster and be smaller or narrower than a regular y equals x squared parabola, and coefficients between -1 and +1 causing wider parabolas. Here's an example using vertex form. The function is f of x equals 3x minus 1 squared minus 2. And if I look, the vertex is at +1, -2. Well, in the function, the 1 is negative and the 2 is negative, but the vertex is at +1, -2. So the formula of vertex form has a negative as part of the formula, x minus the x coordinate plus the y coordinate. So when you go to find the vertex, remember that the number inside the parentheses is going to be the opposite of where the vertex is. Now using the 3, I know that I'm going to go over 1 and up 1 squared times 3, or up 3. And I'm also going to go over left 1 and up 3. So I get those 2 points added onto my parabola. And there they are. Okay? So the first thing to know about vertex form is that the vertex is at the point h, k, where h is the opposite sign of what you see inside the parentheses. And from that point, you go over 1, up 1 times the a coordinate, over 2, up 4 times the a coordinate, and over 3, up 9 times the a coordinate. So that's how you draw a parabola using vertex form. The vertex is also called the minimum. If the parabola is facing upward, this point here is called a minimum, and you say that the minimum, which is the y value, occurs at x equals whatever the x coordinate is. The other thing that is labeled on a parabola is usually an axis of symmetry. A vertical line through the x-axis, or through the vertex, has the equation x equals whatever number. So the axis of symmetry, usually drawn as a dashed line, goes through the x coordinate and has the equation x equals 1. So to summarize vertex form, f of x equals a, which is the scale factor, x minus hk, where h and k are the coordinates of the vertex. Again, watch out for the signs. H is negative, or opposite of what you would see inside the parentheses, and k is going to be the same sign as what you see in the function, and the axis of symmetry is that x equals h. So the last thing that we need to do is go over how to convert from standard form into vertex form. And the first example we'll do looks like this. this is in standard form. Y equals 2/3 x squared plus 4/3 x minus 1. And let's make that a little bit bigger so we can see it. The process of converting standard or general form into vertex form is completing the square. And the steps for completing the square are right here. So the first thing we need to do is move the constant term off to the right and out of the way, and at the same time factor the leading coefficient, which we call a, out of the quadratic and linear terms. So on this function here, I'll have y equals, I need to factor out 2/3, so I'm going to say 2/3 when I factor out the 2/3, I have x squared on the inside, plus, we got to be careful here, 2/3 times what is 4/3? Well, I think that's going to be 2. And now I need a space to complete the square. And then that constant term up here in step 1 says move it off to the right away from the other. So outside the parentheses, I'm just going to leave some spaces and say minus 1. Let's make that bigger so we can see what's going on. Now completing the square is the same thing it was in the previous chapter. You look at the middle term, which is called the linear coefficient, cut it in half, and square that. So inside the parentheses here, since I see a 2, half of 2 is 1, and when I square 1 I get 1. So I'm going to add 1 inside the parentheses. The only problem is, because of this 2/3 sitting outside here, I didn't really add 1 to my function. I added 2/3 times 1, which is 2/3. So if I make this a different color, 1 times 2/3 is 2/3. I need to offset that by going outside the parentheses and subtracting a 2/3. And so the net effect of the two things in red is that I haven't really changed the original function, but the material inside the parentheses is a perfect square trinomial, and the stuff outside the parentheses gets modified to offset what was done inside the parentheses. So now I think I have two-thirds the parentheses now factors into x plus 1 squared, and a negative 1 and a negative 2/3 is a negative 5/3. And so we have converted the general or standard form of a quadratic into vertex form. I know that my vertex has the ordered pair opposite sign on the inside is negative 1. Y coordinate is negative 5/3. I know that my axis of symmetry is the x coordinate. X equals negative 1. And I know that my minimum or maximum, in this case it's going to be a minimum because the a coefficient is positive, which means the parabola opens upward. The minimum is negative 5/3, and it occurs at x equals negative 1. And there you have it. So that's how you convert standard form into vertex form, and you can pretty quickly graph a parabola starting at the vertex and using the coefficient over 1 up 2/3, over 2 up 4 times 2/3, and over 3, which is then you move up 9 times 2/3. So we're not going to go over graphing right now, but here is a second example. At this point you should pause, work this out, and see what kind of an answer you get. Okay, hopefully you worked it out. The steps are again, factor out the a coefficient and move the constant off to the right. So negative 3 left behind is x squared. When I factored a 3 out of a negative 3 from 12, I think a negative 4x was left behind. I'll leave a space to fill in that term. And on the outside, I have negative 8. When I go to complete the square, I need half of the middle term, which is negative 2, and then I square that and get a positive 4. So I'll replace my space with a positive 4. I didn't really add 4 to the function, however, because 4 is inside the parentheses. It's being multiplied by negative 3. So what I really added was a negative 12. I'll offset that by adding a positive 12. Double checking. I think that this positive 12 does offset that negative 12. I'm ready to factor. Negative 3. The middle parentheses factors into x minus 2 quantity squared. And then a negative 8 and a positive 12 is a positive 4. So I think my parabola has a vertex at 2, 4. Again, watch the sign on the x-coordinate because that's negative. That stays positive 2, positive 4. My minimum is my y-coordinate, which is 4. And it's at x equals negative 2. Since the a term is negative, that means that the parabola opens downward, and this really isn't a minimum. This is a maximum. So you can determine a maximum or a minimum without plotting as long as you pay attention to the sign of the x-coordinate. And the axis of symmetry x equals whatever the x-coordinate is 2. Okay? So that's everything we needed to know for section 4.2. Vertex form, if a is positive, if a is negative, if a is bigger than 1, if a is smaller than 1. Know how to find the maximum or the minimum and where it's located, the axis of symmetry, and how to convert from standard form to vertex form using completing the square.